Assalamualaikum warahmatullahi wabarakatuh, and a very good day. I am Siti Arina binti Muhammad Saleh from section 4 group 3. So as for today, we are going to present our experiment, which is a Pelton wheel turbine. Moving on to the background, a Pelton wheel or a Pelton turbine is a type of hydro turbine which is used frequently in hydroelectric plants. One or multiple jets impact a wheel's bucket. The forces exerted by the jet act at right angles to the bucket in order to produce torque, which then cause the wheel to rotate. The aim of the experiment is to analyze performance characteristics of Pelton wheel. Thirdly, the turbine is a water wheel that has been upgraded. Basically, when the Pelton wheel is driven with a broad head, it is likely to be more effective. The torque and also the power are to be viewed as a function of the turbine speed. Problem statement. So basically, a Pelton wheel turbine energy was flowing water has been popular due to the demand on source of power supply from humans all over the world. Thus, the study about the source of power supply from Pelton wheel turbine should be conducted through the experiment. Pelton wheel turbine experiment will give data about the effect of changes in rotational speed with the condition of constant pressure and flow rates towards output power and also efficiencies. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMED bin Saidi, MA18158. For our objective, to get a better understanding of the Pelton turbines and configuration and performance, and to determine power curve characteristic, to generate data on output power and torque as a function of speed, to evaluate the system performance, and to identify the most efficient phase. For our scope is to ensure that everyone in the laboratory is safe. Many precautions must be practiced both before and during the experimentation phase. To start, avoid overfilling the drum with liquid, as this will allow it to splash into electronic equipment. The pump must have a constant supply of water to avoid cavitation. A student must make sure there is no visible electrical wires near the valve as a safety measure.
Hi everyone, my name is Lim Zhen Wei, and now I will continue with the part of theory. A Pelton wheel is an impulsive type of water turbine invented by American inventor which is Lester Allen Pelton in the 1870s. The Pelton wheel extracts energy from the impulsive of moving water as opposed to water's dead weight like the traditional overshot water wheel. Many earlier variations of impulsive turbine existed, but they were less efficient than Pelton's design. Water leaving those wheels typically still had high speed, carrying away much of the dynamic energy brought to the wheels. Pelton's pedal geometry was designed so that when the rim ran at half of the speed of the water jet, the water left the wheel with very little speed. Thus, this design exerts most all of the water's impulsive energy, which allowed for a very sufficient and efficient turbine. When we come to the designs, the Pelton turbine has a very simplistic design. A large circular disc is mounted on some sort of rotating shaft known as a rotor. Mounted on this circular disc are cup-shaped blades known as buckets evenly spaced around the entire wheel. Generally, the buckets are arranged in pairs around the rim. Then, nozzles are arranged the wheel and serve the purpose of introducing water to the turbine. Jets of water emerge from those nozzles tangential to the wheel of the turbine. This caused the turbine to spin as a result of the impact of the water jets on the buckets. The operation of a Pelton turbine is very simple. In this type of turbine, high-speed jets of water emerge from the nozzles that surrounded the turbine. These nozzles are arranged so that the water jet will hit the buckets at splitters, the center of the buckets, where the water jet is divided into two streams. The two separated streams then flow along the inner curve of the buckets and leave in the opposite direction that it came in. This change in momentum of the water creates an impulse on the blades of the turbine, generating torque and rotation in the turbine. The high-speed water jets are created by pushing high-pressure water through nozzle at atmospheric pressure. The maximum output is obtaining from a Pelton turbine, which when the impulsive obtained by the blades is maximum, means that the water stream is deflected exactly opposite to the direction at which it struck the bucket at as well. The efficiency of this wheel is high as the speed of the movement of the cups is half of the speed of the water jet. For the efficiency of Pelton wheel turbine, we have four types of efficiency that we can calculate. The first one is hydraulic efficiency. It is the ratio of power generated by the runner of the turbine to the water energy supplied to the bucket of the runner. Its formula is power developed by the runner divided by power supplied in the inlet of the turbine. For the second one is mechanical efficiency. It is defined as the power available at the shaft to the power produced by the runner. Its final formula is P divided by power developed by the runner. The third one is volumetric efficiency. It is a ratio of the actual quantity of writing on the runner blades per second to the net quantity of water supplied by the jet to the turbine per second. It is also known as volumetric efficiency. Its formula is quantity of water actually streamed at the runner divided by quantity of water supplied to the turbine. For the fourth one is overall efficiency. It is defined as a ratio of the power available at the shaft to the net power available at the base of the nozzle. Its formula is power available at the turbine shaft divided by power supply at the turbine inlet. For the advantage and disadvantage of Pelton wheel turbine, its advantage is the Pelton turbine is the most efficiency of hydro turbine. It operates with a very flat efficiency curve. It operates on the high head and low discharge. It has a tangential flow, which means that it can have earlier axial flow or radial flow. Pelton wheel turbine is also a very easy assembly. When we come to the disadvantage, the efficiency decreases very quickly with the time. The turbine size runner, generator, and powerhouse required is large. And finally, the variation in the operating head is difficult to control because of high heads.
Assalamualaikum. My name is Syed Kuikmal Irfan bin Tuan Kasmadi. My metric number is MA18123. So I'm going to present about method and procedure. So as you can see here, there are 9 procedures that we need to do in this experiment. So the first step is we need make sure the connection of the water are checked so that there has no leakage in the hydraulic bench. So next, the spill valve is completely closed, or we need to turn it fully clockwise. So the number 3 is when begin the hydraulic bench and gradually open the control valve while opening the spear controller until the bench flow is at maximum and the spear valve is fully open. So the step number 4 is hydraulic bench used to measure the initial flow reference, and the inlet pressure is known. So number 5 is the tachometer is used to measure the maximum of the turbine. The tachometer is put against the clear glass at the back of the turbine, and it is used to detect the reflective sticker on the drum. The tachometer reading will vary slightly in time. So next, the average rotational speed is estimated over the course of a few seconds. So step number 7 is the volumetric flow rate is determined by plugging up the drain at the bottom of the bench with the drain column. So step number 8 is the water line on the side of the bench is observed, and the timer is started when the water line reaches 0 liters and it is stopped when it reaches 10 liters. The volumetric flow rate is obtained by dividing the 10 liters. So the last step is the experiment is repeated with reducing the RPM. So as you can see here, there are a few pictures.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMED. My metric ID is MOINUDDIN. So I am from group 3. So our group will discuss for the Pelton wheel experiment. So I will be explaining for the chapter 4 of the Pelton wheel, which is the results and the discussion and also the graph. So the data given at the column, so the pipe is fully open, constant at 0.2 bar pressure, and constant volumetric flow at 30.9 liter per minute. So we can see that the efficiency will be highest at the lowest rotational speed, and the power out will be the highest at the lowest rotational speed. So the movement of the shaft on the shaft will also highest at the 647 RPM rotational speed. So this is the second data that's given. This is the rotational speed. So we can see that the power out is maximum at 330 RPM, which is 1.21 watt, with the power out is decreasing as the rotational speed is increasing. So this is the graph that have been generated using Excel. So for the rotational speed versus movement on the shaft, we can see that the rotational speed, the moment on the shaft will be decreased as the rotational speed is increasing. The power out will be increased if the rotational speed is decreasing. The efficiency of the Pelton wheel will be decreased as the rotational speed is increasing. And the last one is the power curve. We can see that the maximum power generated is 1.21 at 313, I think. So for the discussion, the efficiency of the wheel and the rotational speed of the wheel is directly proportional. The drop of the efficiency is caused by the decreasing volume of water that hit the bucket, as the absolute velocity of the bucket is higher than the water. The power curve is mainly affected by the volumetric flow rate, which we can see that if the more water hit the bucket, so more power out will generated from the experiment. Next, the power output increase as the maximum power output is at 1.21 watt at the rotational speed of 330 RPM. So we can see that the power output will be generated if the water hit the bucket at the certain time and certain volumetric flow rate. So for more information, doctor can refer to our report.
Assalamualaikum, and my name is Ikmal Irfan bin Tuan Kasmadi. My metric ID is MA18123. So I am going to present the conclusion. So first and foremost, the purpose of the experiment is to design and test a full fluid flow calculation methodology and experimental process, as well as to determine the output and efficiency of a Pelton turbine under various operating conditions, since we start from higher rotational speed to low. The result experiment was measured and coordinated by coordinator. Then the graph of efficiency versus rotational speed and graph power out versus rotational speed are obtained. Finally, at the close of the experiment, all of the specified objectives were met. To create a more efficient method, please make sure to minimize situations like losses and friction. So that's all from me. Thank you.